So we're going to go through these challenges. The very first one is this temperature converter. So the challenge here, you're going to create logic that's going to convert temperature from Celsius to Fahrenheit and vice versa. So what we have to do here, we're going to enter a value on this numeric thumb wheel here. We're working in the I/O simulator. So we're going to key in a value here. We're going to get that number in the PLC. We're going to convert that from Celsius to Fahrenheit or from Fahrenheit to Celsius. And we're going to display our result over here on the LED output display. I'm giving you the formulas for these. So basically, a degree Fahrenheit is equal to 9 divided by 5, or 1.8, times the temperature in Celsius plus 32, or the opposite of that, Celsius is equal to the temperature in Fahrenheit minus 32 multiplied by 5 over 9. So that is the formula for converting temperature to Fahrenheit, temperature from Celsius to Fahrenheit and back and forth. The other thing I'm asking for you to do here is let's put in an input switch. So let's use one of these inputs over here to basically switch our conversion from either Celsius to Fahrenheit or from Fahrenheit to Celsius, depending on what that input switch is doing. So let's look at our logic that we need to do this. So the very first thing we're going to do, we need to be able to put in a number from the thumb wheels and use them in the PLC. So if we look at how to do this, we will notice that I'm just going to do a move instruction here. And as we know, this move instruction is not going to work. So the address for this thumb wheel here is I:5. So that represents the 16 bits here. This is a 16-bit word. So if I take that and just move that to N70, I'm just going to start using numeric registers here. If I start doing this, I download that and run it. And basically, as I put numbers in here, I should be able to see stuff come in over here. Now what you're going to see, I have 0131 or 131. That is my number that I want to see in the PLC. The problem is, because this data entry thumb wheel device is wired up in BCD format, if I just take the value of that register, it doesn't show me 131, it shows me 305, because 305 is the binary representation of these 16 bits together. Because the way that this thing is connected, this basically looks at this as these first 4 digits here represent a 1. This next group of 4 digits represent a 3. This next group represent a 1. And this last group of 4 bits here represent a 0. So we're basically using a 16-bit register broken up into 4 groups of 4 to represent these 4 numbers. But our PLC sees this as one 16-bit number, which it calls 305. So that's no good to us. So what we need to do is we need to convert this register from BCD into a number we can use, because we want to get 131 in the PLC. So the way that we do that is we use this from BCD command. So from BCD is going to convert this string of bits into the proper number that we can use. So if we do this and run this instruction, now you will see we get 131. So whatever we put in here is going to show up properly over here. Whatever number we key in shows up properly in this N70 register. Now we're good. We can start using this. The second part here, we need to do some math. So our math that we needed to do we had a formula that was basically our temperature. We're going to say, let's do the conversion. We're going to enter in, let's enter in a temperature in Fahrenheit, convert it to, let's enter in a temperature in Celsius, convert it to Fahrenheit. So we're going to take this number, we are going to multiply it by 9, divide it by 5, and then add 32. So C is what we're entering in, multiply by 9, divide by 5, add 32. So to put together a formula like that, we use our math instructions. So that was a multiply, a divide, and an add, all together in a row. So our number that we have coming in here is currently located at N70. We're going to multiply by, that was a 9. Now we need to make some intermediate steps here. So I'm just going to start picking registers. I'm going to say N71. And then I'm going to take that N71, do my next operation with it, which is divide by 5. Put that into N72. I could be picking any registers as long as I'm not reusing them here. I'm just going 0, 1, 2, just because that makes kind of sense to go in all in order. And the last thing I'm going to do is I need to add 32. So N72, I'm going to add 32. Now let's put that in N73. Now if I run this, and I get 2,267. And what we should see is as I change this, my numbers over here change as well. So this should be the Fahrenheit equivalent of this. So let's test this. I know that 0 degrees Celsius is 32 Fahrenheit. So if I set this to 0, I get 32. I know that 100 degrees Celsius is 212. That's the boiling point of water. When I put in 100, I get 212. That's right. I know that, what else? 22 is room temperature. 22 should be about 72 or 71. And 37, that's body temperature. That should give me like 98. So it looks like my math is correct. That's calculating everything correctly. So the other thing I want to do is take this number here, this 98, display it on here. And once again, we run into this problem of I can't just move this. If I try to move this to output 6, output 6 is the value or the address for this output register. If I try to do that, I get 62 here. So I get a number that's all screwed up. Basically, I want to see a 98 here. Right now I want to see a 278 here. But that's not what I see. I see 116. So I'm seeing that because the value I'm putting in here, that is a binary number. This thing, that needs a BCD version of that number in order for it to display properly. Because this device is wired up in a BCD format. So the way that we do that, instead of that move instruction there, that needs to be a to BCD instruction. So we're going to take our result, convert that to BCD, and put it in output register 6. That's going to give me some crazy number, what it looks like over here. It looks like it's putting in 632, but the BCD converted version of that is 278. 278 is what I should be seeing. So let's go through my things again here. 100 degrees gives me 212. That's my conversion. 0 degrees gives me 32. 22 should give me 71. 37 is going to give me 98 degrees. Body temperature. This is Celsius. This is Fahrenheit. This is converting it all nicely, displaying, bringing in a value, converting it from BCD to a number I can use in my PLC, doing the math on it, and then displaying it in BCD again over here. So, final part of this. This is converting Celsius to Fahrenheit. I want to add a switch over here that I can basically toggle a switch and have this convert Fahrenheit to Celsius instead. So, to do that, I'm going to pick an address here. I'm going to say if this input is on, use this math. I'm just going to copy this run. Paste it down here. I'm going to say if that address is off, use a different set of math. I'm going to take this. My formula for this was instead subtract 32, multiply by 5, divide by 9. So math instructions here. So this was N7, 0, subtract 32. I'm going to make some new registers here. I'm going to say N7, 10. And then I have N7, 10. Multiply by 5. Put that in N7, 11. And divide N7, 11 by 9. Write this into N7, 12. This goes away. We're going to take N7, 12. Write that into my destination. So now we are going this way. So that is my Celsius conversion. Now I should be doing Fahrenheit degrees to Celsius degrees. So what do we know is equal here? 32 should be equal to 0. This is freezing point. 212 should be equal to 100. 98 should be equal to 37. Pretty close. This might be off a little bit because of the rounding errors on the math. And what else do we have here? 72 should be about equal to 22. All right. So that is that challenge functioning properly. So that is the logic. Oops. Anyway, that is the logic for this challenge.